two speakers. First, we're going to have Yuval and Tom Perel presenting, and then Cheryl Ade is going to go after. If you guys have questions, please hold them until the end. So this talk should go on for about 10-15 minutes, right? And then we'll hold out questions at the end, and then Cheryl will have them as well. So Yuval and Tom are going to talk about quantifying the correlation between Levenstein edit distance and accuracy of AI detectors. So, guys, take it away. Thank you.
All right, so we wanted to explore, essentially the Levenstein edit distance is how much you change a word or a sentence or a whole paragraph, and the edit distance tells you how much you changed it, and we wanted to see if that relates to how the AI detectors can detect if a text is AI or not. So the contents that we'll go over, the issue, that's what we want to see if the edit distance relates to the AI detection, and then we're going to briefly go over how AI detectors work as a whole, so we can better understand why, if the edit distance causes the AI detection, why that happens, and then how we achieve that, our methodology, and then we'll go over the results of our data and a few takeaways. So in the recent years, students mostly have seen a high influx in AI usage, so students will use it for their essays, assignments, and the teachers and administration have begun to notice that, so they've begun to use AI detection, like Turnitin.com or GPT-0, so they could see if a student is using AI or not, and yeah, that's essentially the school usage of AI detection.
So to understand how the AI detectors actually work, it's important to see that they're all built on the transformer architecture, which is what all the LLMs are built on. So Gemini, ChatGPT, all of those are built on the transformer, which uses context and tokenization to predict basically what the next token or next word, whatever you want to think of it as, in a sequence. And so it's really just a matter of statistics and predicting what the next token is going to be. So the way they work is sort of reverse engineering how that works. So it's really based on two things. One is the predictability. So for example, if I say the declaration of, everyone here immediately would think of independence, right? That's the most probable next token in that sequence. So it uses that at a greater level essentially to figure out, to see if it matches up. So if everything is very predictable, then that's a good sign that AI likely wrote it. And the second is variation. So when humans write, we usually write with a varying length and rhythm to how we write, right? You can have a long sentence followed by a short sentence. We don't keep it the same most times. AI, on the other hand, does usually do that. And so that's how you know that if there's a higher variation, then that's very likely a sign that a human wrote it. So our methodology, we started off by generating prompts and essays for 5 different academic categories. We got an initial AI detection score by setting up a Google Colab. The initial AI detection score, we used GPT-0, which is used to basically test what's the probability that this was, that AI was used to create this piece of writing. And after that, we set up a Google Colab, some code to find the readability score and the readability level of each essay. And then we put them through a paraphraser named Quillbot, which is used to change writing into a more humanized version. And then we ran the Colab again, the code, to find the edit distance. And then that's how much the writing actually changed. And then we also ran the AI detector again on that edited essay. And then we just compared the results.
Now, to go more into what paraphrasing is, we used 2 different modes in Quillbot. We used the standard mode, which uses less temperature, and essentially what temperature is as we saw it, it's all just probability. So it looks less temperature, meaning the paraphraser will take less of a risk when changing the word. So if it changed the word from, I don't know, writing, it will go to like typing or something similar. But a more creative, so more temperature, which is what the creative mode does, it takes more of a risk. So it'll take the less likely next word, and that could change the whole flow of a sentence, change the logic, change the tone. As we heard earlier, AI writes very monotone, it keeps the structure of all the sentences very similar, which standard doesn't deviate far from that, but the creative mode, it goes further away, more towards what a human would write. It could change the flow, it could sound a bit funkier, but it would help in AI detection. So from our results from our data, this was a graph of the average edit distance percent for standard and creative. And as we can see, standard, it changed like right below 60%, and creative changed towards the 65% area, meaning creative actually changed more, which makes sense because it takes the less probable change, so it'll keep changing more and more, and the whole sentence structure will seem different, while standard keeps it like primarily the same, which is why you see less of an edit distance. Now, this is for the readability score, and the readability score essentially says how easy it is to read the sentence. So is it high complexity words, and is the sentence structure easy to follow? And as we can see, standard, it didn't change a lot in the sentence structures, and creative changed a lot more, showing us that, again, the creative mode changes a lot more in the sentence structures, the paragraphs, and the essays that we generated, while standard tends to remain the same while only changing a few aspects. Now, this is the readability level, essentially saying what, in a sense, grade level the text is. So if it's a higher, that means the text is at a higher reading level, and you require more reading capabilities to understand it. So both of them actually went down in levels, which in a sense makes sense because the AI at the start, we told it to generate at a very high level, at a PhD or postgrad level essays, and standard went down around 0.75 on the level, and creative went down more towards the 1.5, meaning again creative not simplified, but it changed the words into the less probable next outcome, which essentially lowered the grade level as a whole, while standard kept the similar words that could have been higher level words, which is why the standard didn't change the level that much. And finally, the detection difference, which is what was really important. We saw that standard went down around 0.3 on the average, and this rating is on a scale from 0 to 1. 0 meaning there was no AI used at all, and then 1 meaning it's 100% AI. So both of these are actually very impressive, how much they went down. That means it's about 30% change for standard, and for creative it's more towards the 40%, which, as we could see, again, the creative, it did manage to evade the AI detection. Even though both of these texts were completely AI generated, the creative mode was able to have a greater impact on lowering the detection score, while standard was not, which is what we predicted. All right, so a few takeaways. Again, paraphrasing. We determined at the end that the creative paraphrasing mode was actually better to actually show a better evasion of AI detection, which makes sense as it uses the less probable. It's all about statistics, so if it uses the less probable next change for a word, then the AI detector notices that and doesn't assume that it's AI, it assumes that it's human written. And then the AI essays as well. We put them all the prompts through Gemini and the fast mode, and it created all the essays for us. And you can see that although they were all created very quickly and at a high level of reading level, they were all completely 100% AI. The initial AI detection score was close to 100% for all of them, meaning even though we generated very high level essays, it was still AI detectable.
third, about the edit distance. So we saw that the higher edit distance there was, the more text was changed, the lower the average AI detection score. So a good way to sort of measure if AI was used is actually by, changing. If you're able to change an AI written essay, it's very likely gonna pass the AI detection. And lastly, this really shows that AI detection isn't proof. Because it works on probability, it's always bound to make mistakes. There were a few cases where even in our first essay, like the initial AI generated essay, it actually didn't flag it as 100% AI, even though it was. And so, really, what it's meant to show is that you can't 100% trust these tools to see if AI was used. Thank you.
Itself, you can use the AI to beat the AI.
So it was Quillbot is a sort of different. It's not like it's not integrated into ChatGPT or Gemini. If you do those, that might be different results. I'm not really sure, but for our methodology, we use Quillbot, which it has its own algorithm for how it changes words up. So, but it works very well for.
Because I've seen the other problem too, where I've actually written something that was written by me, and I put it into the AI detector just to see, like, when I was first learning about these and how they work, and it said it was 100% probable of it being AI. So I'm glad you guys said that, like, you can't actually, like, I know some schools have tried to, and I think a teacher got in trouble for saying that a student cheated because the thing he turned in said it was 100%. But how do you know if it isn't one way or the other?
That's the issue.
Any other my question, those tools are from the perspective of the instructor, make sure that students are being honest. But again, if you were the student, how would you use those tools to prove, hey, this is me? I mean, even 30 years ago in college, I was, we did a perfect essay, and then we were told we cheated because we followed exactly the instruction from the professor, and it was so perfect that we all failed because it was too perfect. So it's the same thing, like how would you, how would you as a student say, come back and like reverse the same process to prove, oh, this was totally me. Versus getting that because you can't prove it. Is there a way that you guys?
No, not really, and that's sort of the issue with it, is that it punishes students who are very good at writing, because a lot of the AI it's trained on billions of parameters, and like it has so much training data that it really tries to just take from like the best and like most probable things, and a good student would also likely do the same. Like we work kind of in the same way, that everything we do is sort of based on our past experiences. So like if whatever you read, whatever you do, then you'll write in the style of stuff that you read, right? So
that's a very great way to kind of like tell that it's counterproductive for good students who write really well. But is there a way by which you could rank before it gets into the data pool where the LLM is getting trained to say, hey, this is the best research that we got because grammatically or from a language perspective, this is the best. And then LLM kind of learns that, hey, this is the best of all the data that we have. So is there a way by which you can rank the data that's getting fed into the LLM, or is it just learning randomly, putting its own head into?
in terms of writing, like weighting like certain training data is like more than others.
Yeah, if I ask an AI tool, write me an essay on an apple tree, right? So somebody wrote an essay on an apple tree, and it's like one of the best versions, right? So does AI know how to qualify that this is the best written essay on an apple tree? I mean, is there a way to kind of like quantify that this is the best, or rank rather, this is the best, so you probably.
So that's sort of what it does with the the most statistically probable like